In this video, we're going to learn how to graph quadratic equations in vertex form. Vertex form is y equals a times x minus h squared plus k. You'll notice that we have an a, an h, and a k value just like how we've had with linear and exponential functions. They mean the same things that they did with linear and exponential functions. A tells you if you have a stretch, a shrink, or a reflection. This should say shrink. Let me change that. So you will have a vertical stretch when the value of A is greater than 1. You will have a vertical shrink when the value of A is in between 0 and 1. And you will have a reflection across the x-axis if your A value is negative. If you have x minus h, then you'll shift to the right h units. And if you have x plus h, then you'll shift to the left h units. If you have a positive k value, then your graph will shift up k units. And if you have a negative k value, then your graph will shift down k units. So let's look at example 1. So here we want to graph this equation and we want to answer and find these characteristics that are over here on the right. So let's see. First thing I'm going to do is I'm going to identify A, H, and K. Those are your transformations. So A, H, and K are your transformations. So our A value is 2. 2 is a number that is greater than 1. So my graph is going to have a vertical stretch. Then I also have, I have x minus 1. X minus 1 is a x minus h. So that means that I'm going to go to the right 1 unit. And then I have minus 4 on the end. Minus 4 is a k value. My k value is negative, so that's going to go down 4 units. So now I have my transformations. The reason why this form is called vertex form is because it gives you the vertex in the equation. Your vertex is always a value of hk. So this is called vertex form because they give you the vertex. When you find the vertex, you change the sign of h and you keep the sign of k. The reason why you change the sign of h is because in the formula we have minus h. And so this negative is changing the sign of that h value. And so we just change the sign of h and we keep the sign of k. So in this problem, our vertex would be 1, negative 4. And again, that is because we change the sign of h, so we change this negative 1 to a positive 1, and we keep the sign of k, k is negative 4. Once we know that the vertex is negative 1, we can go ahead and find the other x values. So after the number 1 is 2, and after 2 is 3. Before 1 is 0, and before 0 is negative 1. So now we can go ahead and type this equation into Desmos and find our corresponding y values here. So that's what I'm going to go ahead and do right now. So in Desmos, I'm going to type in our equation, which is 2 parentheses x minus 1, close parentheses, squared, minus 4. And then I'm going to hit the settings gear and click on table. And I'm going to change these x values to be the same x values that we wrote down in our notes, with 1, negative 4 being in the middle of our table. And so now we can see this graph and we can see our table. And so I'm just going to go ahead and copy in down those values into our table on our notes. So we have 4, 4, and then -2, -2, and 4. So let's go ahead and plot those points. So we have -1, +1, 2, 3, 4. Remember, x is left to right, y is up or down. Then I have 0, -2, 1, -4, 2, -2, and 3, 4. Once I have those points, I can go ahead and graph my parabola. Remember that parabolas are U-shaped, not V-shaped, so you don't want to make this turning point down here a sharp edge like a V. You want it to be rounded. And then also keep in mind that your graph goes on forever in both directions, so remember to include those arrows. So now that I have this parabola graphed, I can go ahead and find the other characteristics that they're looking for. Our vertex is the point 1, -4. The axis of symmetry is the line that cuts this parabola into 2 perfect pieces. And so that's going to be x equals 1. Remember, it's always x equals the x coordinate from your vertex. Your domain are your x values from left to right. Our graph is going to the left forever, so that's going to -infinity. Our graph is going to the right forever, so that's going to +infinity. So our domain from left to right is from -infinity to +infinity. Our range are our y values from the bottom of our graph to the top of our graph. The bottom of my graph is my vertex. This is where y is -4. My graph is going up forever, so that's going to +infinity. So my range from the bottom of my graph to the top of my graph is from -4 to infinity. If we look at example 2, we're going to do the same exact things. First thing I like to do is go ahead and write down the transformations. So again, your transformations are your a, h, and k values. In this problem, my a value is -1. When your a value is -1, that tells you that you have a reflection across your x-axis. And then I have x plus 2, so that tells me that this is going to go to the left 2 units. And then my k value is +3, so that tells me it's going to go up 3 units. From this equation, I can identify my vertex. My vertex comes from HK. So remember, this is H and this is K. You change the sign of H, so I have a +2, so that will be a -2. You keep the sign of K, K is 3. Once you have your vertex, so again our vertex is -2, 3, you can find your corresponding x values. After the number -2 is the number -1. After -1 is 0. Before -2 is -3. And before -3 is -4. So I'm going to go ahead and type this equation into Desmos. So I'll have negative parentheses x plus 2 parentheses squared plus 3. And now I'm going to click on the settings gear and go to table. And I'm going to change this to match the table that we just wrote down. -2, -1, and 0. And so these are going to be the numbers that I go ahead and write down into my y part of my table. So -1, 2, 3, let's see. -1, 2, 3, 2, and -1. So now I can go ahead and graph that. So I'll have -4, +1, negative, oops, sorry, not +1, -1. So So -4, -1, -3, +2, -2, +3, -1, 2, and 0, -1. So here is the graph of this parabola. Remember that your line of symmetry is a line that goes straight through your vertex. That line is always x equals the x coordinate of your vertex. So that equation is x equals -2. Your domain are your x values from left to right. Our graph is going to the left forever and going to the right forever. So our domain is from -infinity to +infinity. Our range is our y values from the bottom of the graph to the top of the graph. The bottom of your graph is pointing down, so that's going to -infinity. The top of your graph is your vertex, and that is where y is 3.